Hey, it's Josh from Everything Sings, and today we're going to be talking a little bit about some basic vector properties. In the last video, we spoke about vectors and coordinate systems, which are a couple of tools that will help us define things within physics. And now I want to go over just a few vector properties that will help us better understand how we identify vectors, how we describe vectors, and how we use vectors. And so the first one that I want to talk about is now that we have these vectors defined in some kind of space, which we have in a XY coordinate system. You see up here I have an A and I have a B vector, just again arbitrary labels that I've put on them. We want to maybe describe them in terms of this coordinate system. And so this will look very familiar because it'll look just kind of like defining a point in space. And so all we have to do to describe this vector in terms of its coordinate system is just describe what we say its components. So its X component and its Y component. And so this will look like, we'll say the A vector is equal to, and then I'll use a different symbol than a parenthesis, this kind of like greater than, less than symbol looking. And we just simply describe its components. So here I'll just say it's at some position x1 and y1. And then the same thing for the B vector. It would be in some x2 and then y2. And so now we've described this vector in a way that actually makes kind of practical sense to us, because we understand that we simply just need to identify where this is in our coordinate system, and that's what we can say is what this vector is doing. And now I want to talk a little bit about how these vectors interact with each other, specifically through addition and subtraction. And that might not be very clear right now why that matters, but it will later. And we'll need to know how to add these vectors. And so if we first look at its component form, it's pretty straightforward. All we need to do is simply add and subtract these components from each other. So if we have, let's say, the A vector added to the B vector, this would simply just be the components added with each other. So I would just write this as x1 plus x2, and then we have y1 plus. And the same would be true if we were subtracting it. So if we said the A vector subtracting, the B vector, it would simply be x1 minus x2, y1 minus y2. So it's pretty straightforward. It's nothing too complicated, but this notation is a little bit important. It'll be important later when things get a little more complicated. Now that we understand this just in its component form, what really matters though is how this shows itself on the graph. What does the A plus B vector actually look like? Because if you look over here, this is a new vector that we've created. So I want to demonstrate how this works on a graph. I like to think of this when solving this as kind of like a puzzle. And so when you're looking at this A vector and you're saying you're adding the B vector, you're just looking at how do they interact on top of each other. So like I tend to move this B vector on top of this A vector to say, hey, I moved in the A direction, this distance in the A direction, and then I also moved a little more in the B direction for some B distance. And so I'm going to use a different color to demonstrate this. So this is our B vector, and all we're going to do is simply put it on top of the A vector at the end of where this A vector ended. So we see that it moves kind of like in this direction, and I'm going to add that as kind of like a metaphorical B vector, and then I can now actually connect this, and this dotted vector is the A plus B vector. And so a similar thing would apply if we're doing subtraction. One thing that is important to note is that if there is a negative symbol in front of a vector, it simply just flips the direction of all of its components. So the negative vector of B is just in the opposite direction. You could think of that as a 180-degree turn. And so we can use that to imagine how this would work with the A minus B vector. So another way of writing this would actually be the A plus the negative B vector. And so if we think about that in terms of its direction, the negative B vector goes kind of like this way. I'm running out of room here, but it goes about that way. That's kind of like the negative B vector. And so we would do the same thing when putting it on top here to say, oh, okay, well, we start here at the end of this A vector, and then we add the negative B, which would go, let's say, about that seems right. Let's say that, and then connect the dots from the origin, and boom, this is now the a minus b vector that we have right here. Those are a few of the properties that I wanted to talk about here. We'll get some more practice with it, so if it's confusing right now, that's okay, because right now this is just kind of the mathematics of it, but we'll start to see how this makes sense when actually dealing with a physical, real concept.